Namaskar my dear friends. So let us try to understand the next implementation. We have already seen the battery charger IC which is BQ25171-Q1. This is a automotive grade linear battery charger IC which is capable of giving you 800 milliampere current maximum, and this is applicable for all kinds of battery chemistry, that is lithium ion batteries, lithium ferrum phosphate batteries, and nickel metal hydride batteries, that is NiMH batteries. Okay, so we have already seen two implementation for lithium ion, lithium ferrum phosphates. Now we'll try to understand nickel metal hydride. Okay, so we have implementation for 4 cell nickel metal hydride batteries which is going to give you about 5.25 volt output. Okay, so this is the complete implementation, and we'll try to understand how we can design the particular charge current settings, then safety timer charge settings. Okay, and what would be the voltage output setting. Got it? And this is the parameter that we are going to talk about. My charge current would be 100 milliamperes. The charge safety timer will be cut off to 10 hours, and this is going to be having 4 cell nickel metal hydride battery charger plus intermittent charging as well. Okay, so this is the complete design. We'll try to understand how we can calculate all these parameters properly. Okay, so this particular IC is very popular, and why we are stressing for all the three kinds of application is because of very small applications, or handheld devices and all. You try to utilize lithium ion or batteries, or lithium ferrum phosphate batteries, or nickel metal hydride batteries as well. Okay, the beauty is NiMH batteries of 1 to 6 cells it can be implemented. So we are going to see an application for 4 cell NiMH batteries. Okay, so let's try to directly jump into the implementation. So first of all, as you have already seen in the design and detail phase, that this is the battery charger IC that is given in the data sheet, and this is the application that was suggested by the data sheet as well. So as you can see, this particular IC has been designed for 4 cell NiMH batteries, which is this. Here it is your input voltage, and here it is your battery output voltage, which is going to system as well as to charge the batteries both. Okay, and these are the two status pin LEDs, status 1 and status 2, which will be giving you the status of charging or fault conditions or charging completed or all those things. Alright, and this is our temperature safety. So temperature understanding is also there, and we have this particular three resistors which is going to set your charge safety timer, like up to what you want to cut off your charging, and what is the voltage setting at the output of your battery voltage, and what is the charge current that will be going to the battery charger. Okay, so for that, first of all, we will try to freeze our design requirements. Okay, so in the design requirement, what we will do is, what is the input voltage that will be there. So input voltage basically will take up to since the battery voltage is around 5.33 volt max. Okay, so we'll be having the battery the supply voltage around 9 volt or 12 volt or 15 volt. Okay, so these three voltages you can utilize, so you can take this particular application for your 9 volt supply input. Okay, then we have 4 cell nickel metal hydride batteries, and fast charge current we are going to set to 100 milliamperes. Okay, we want to charge it bit faster, and then we have the recharge voltage that is there. So as it has been calculated for 4 cell, so they have considered for 1 cell battery it is 1.33 volt. So this is how you will be getting the battery voltage maximum to 5.32 volt. Okay, basically for NiMH batteries it is 1.2 volt minimum or nominal voltage for 1 cell. Okay, so for 4 cell what will be the total voltage? It will be around 4.8 volt. Okay, so this is how you will be getting the battery voltage nominal, but maximum you can get up to around 5.5 volt as well. The charge safety timer will limit it to 10 hours. Okay, so with these informations we are going to set this particular understanding. The battery temperature sense will be utilizing NTC, which is inbuilt in the battery pack. Okay, and we will be extending our battery temperature window, which will be going to 0 to 60 degree centigrade. Okay, earlier we have already designed to 10 degree centigrade to 45 degree centigrade for lithium ion batteries, okay, and lithium ferrum phosphate batteries. But here in this example, we'll try to go ahead little bit wider temperature range. So for that purpose we are going to have a series resistor. Here you can see series resistor and parallel resistor 400 kilo ohm. Okay, now let's get into the design. So this is the designed circuit that is there. So we have taken one input connector which is there from Worth Electronics, 2.5 mm pitch. Okay, this is a very good connector. Now this is my input voltage which is going to be 9 volt. Okay, power supply is 9 volt. Even if you want, you can take up to 12 volt adapter as well. These two capacitors will serve the purpose to remove the all the transients or dips. Okay, coming back to the output side, so we have the system load here to go to the system using this particular connector, and this is the battery that is going to be charged. Okay, so this is having inbuilt NTC, let us suppose. So in inbuilt NTC, what we have done is we have connected the series resistance which is 1.9 kilo ohm and the parallel resistance which is 400 kilo ohm to set the like temperature safety from 0 degree centigrade to 60 degree centigrade. Got it? Now we have two status LED, status 1 and status 2. So those two has been connected using 3v3 supply, okay, from outside. So that is going to like give you these red LED and green LEDs. Okay, so based on the understanding of the LEDs, whether they are blinking or they are continuously glowing, you will be having what is the charge status. Okay, so we have already seen in our design and detail phase, which you can see video number 55. Okay, so in this series you will see what is the status LED indications. Okay, now our requirement was 100 milliampere charge current and 10 hours is the charge timing, and 4 cell plus intermittent Vset will be the Vset voltage. So these three resistors will be set accordingly. So based on the calculation, I will just show you how to calculate these particular values. To set the charge current to 100 milliamperes, the ISET values will come up to 3 kilo ohm. Okay, the charge safety timer will resistor value will come up to 18 kilo ohm and the voltage setting will come to 11 kilo ohm. So let us open the Excel sheet where design is there. Okay, so this is the design for 4 cell lithium ion batteries. We have set ISET current to 100 milliamps. Okay, so you can see the fast charge current setting resistor value is coming to 3000 ohm, that is 3 kilo ohm. Okay, so we have 3 kilo ohm. Coming back to charge safety timer, so charge safety timer, what will be there? If you see table number 7.1, for 10 hours you will get 11 kilo ohm, sorry, 18 kilo ohm. So just go to this particular table. Okay, coming back to here, so as you can see, for 10 hours we are going to see NiMH batteries for 18 kilo ohm. Okay, so this is what you are see. If you want to increase the like charge safety timer to 16 hours, you have to utilize 8.2 kilo ohm. Okay, so this is very easy, nothing more than that. Now coming back to other parts, we have to have voltage setting. So voltage setting, you have to see table number 7.2 which was there in the data sheet. So for NiMH battery is this one. Okay, so we have 4 cell this one and 4 cell plus intermittent charge. So if you want to have 4 cell plus intermittent charge, okay, then you have to put 11 kilo ohm at the Vset voltage. Okay, so this will be the chosen value. If you do not want intermittent charges, then only 15 kilo ohm will be sufficient. So this is how you have set your values to 11 kilo ohm and 18 kilo ohm and 100 milliampere for that 3 kilo ohm. So this is how we have got the values 3 kilo ohm, 18 kilo ohm and 11 kilo ohm. Okay, let us say you want to decrease the like charge I charge, that is, let's say 60 milliampere you want to make. So for 60 milliamperes, what will you do? You will put here 60 milliamps. So in that case you will be getting R I set as 5 kilo ohm. So hope you have understood this particular design. So this was our last design for this particular IC which we have studied, BQ 25171-Q1. It is an automotive grade IC. So we have seen three applications. One is from lithium ferrous phosphate, okay, another one is lithium ion batteries, and this one was NiMH batteries, okay. So hope you have a good understanding of how to design linear battery charger using very simple IC, which is BQ25171. And if you do have any questions regarding this, how to set the particular current or voltage setting or the charge cutoff timer, okay, or how to select the input connector or output connector, or what are the different parameters for selecting the various capacitor values. So let us say you will be getting here V output as 5 volt, okay. So the capacitor voltage rating must be 10 microfarad of 16 volt minimum. So 16 volt or 25 volt or 35 volt, you can go ahead, no problem, okay. But do not take less than 16 volt, because it is a ceramic capacitor, so their derating curve is very sharp, okay. So still, if you do have any questions regarding this, you can reach out to me, and I will try to solve your all doubts as well. So alright guys, thank you.